But for those who are prepping for that, I would say wait a little bit because the 2026 code book is going to be coming out next year, and I believe that that's the code book that we're going to be using for next year.
So you will provide to us like handouts and things, or
I will,
we read
when you come and enroll in November, or when we finally finish enrolling in November, we'll give you a list of materials that you need for January. January is when the class starts. Yeah, that's a good question. But in my class, I don't really ask for you guys to buy any books, because what we did with Mr. Pierre is that we created a curriculum for you guys. So that's why I require the binder, because we will be giving you a lot of articles. We will be giving you guys a lot of new nuances, because we don't want to fall behind as a school. And there are a lot of things that are coming out in electricity all the time that we want to incorporate in the class. So we don't really just base it on a book. We take the most important parts of the field, and you guys in Mod 1 will create one binder for residential. In Mod 2, you'll create another binder for commercial and industrial. In Mod 3, you will create a binder for motors, motor controls. And then in Mod 4, you will create a binder for PLCs and also for logic controls. So those are the trainers that you guys will be using. And those are kind of like the cherry on top, because a lot of schools do not have this kind of technology. But this Bassett Adult School spent about $20,000 to $25,000 to get trainers for all of their students, plus laptops, which are in that case right there, so that you guys can learn how to use logic, which is being used in industrial right now for robotics. Now this is just a precursor for robotics. It's just an introduction. If this is what you guys like, then you guys need to go ahead and get specialized in robotics or get specialized in industrial controls. A lot of the students will love, for example, they'll love residential, right? This is something that they want to do. They want to focus only on residential, which is good. A lot of students during Mod 2, we show them how to bend pipe. So they'll love how to bend pipe, and they'll get specialized in pipe bending. Other students will hate bending pipe. They'll hate residential, but they love motor controls and motor control, and they'll love how to be able to use the variable frequency drivers, how to be able to use sensors, because this is something that we teach here in the class, how to be able to use all of these sensors and how to be able to troubleshoot them, right? Because a lot of people can follow instructions, how to be able to install them, but troubleshooting, that's something that not everybody knows how to do. So Mr. Pierre has a very intense class teaching you guys how to troubleshoot electronics, how to troubleshoot motors, how to troubleshoot transformers, how to troubleshoot contactors, relays, and all of these components that you use for electrical installations. So, now, I need you guys to keep in mind that if you don't like residential, and you don't like bending pipe, and you don't like motor controls, maybe you're gonna like PLCs, programmable logical controllers, right? But you gotta complete all of them in order to get that final certification. Because I have students that when they're residential, they're like, I don't like residential, and I'll tell them, keep on going, because maybe you'll like pipe bending, but they'll drop out, right? So that certification or that certificate that they got for only Mod 1 is trash. They can throw it away in the trash because it's useless. You have to get all 4 certificates to be able to take that test. So if you just complete Mod 1, you have a certificate of completion. That's it. If you just complete Mod 1 and 2, you just have certificates of completion. If you just do Mod 1, Mod 2, and Mod 3, you just have certificate of completions. If you do Mod 1, 2, 3, and 4, now you have a career certificate. That career certificate is what you guys are going to give to be able to get that test. So one of those certificates is useless, but all 4 of them will allow you to take that test for that license or that certification that you guys want, okay? So this is a journey, guys. This is something that you're starting just right now, And you have to understand that you will have obstacles, you will have a lot of things that will come up in your life that will want to deviate you from getting to that goal. But if you guys are focused and laser focused on what you want to do, then you've got to make a plan. You've got to think about it. Okay, I'm going to be 6 months in intro, and then I'm going to get into mod 1. Then you got to count how many months, so your goal is going to be for 2027. 2027, I'm going to be graduating from Bassett Adult School, and I'm going to be able to take that journeyman test. So it sounds a lot right now, but if you guys start counting your steps, okay, 2 months down, 3 months down. When you see you guys are going to be in 10, 12 months, and you're going to have like 8 months left. You get me? So you got to have that mentality of, I need to get to that finish line. Because 100% of us, everybody here in this class wants to get to that finish line. But unfortunately, maybe like 5 of you guys are going to get there. And I'm telling you guys, I don't want this class to decrease. I want you guys to all get to that finish line. But unfortunately, some of us are kind of, we get discouraged too easily, right? Oh, I'm not really good with math. Oh, I hate reading. Oh, I don't really understand, but I'm not going to ask the teacher because I'm embarrassed. No, don't worry about it. One of the things that I got trained by my dad. My dad is a general contractor, and he's going to come and see you guys because he always loves to come and talk to my students. So I grew up with him, and one of the things that he always told me is if you don't ask questions, then you're going to always ask, or always have that doubt. What was the answer? So always be that person that if you have a question, ask it, because other people might have that same question, but they just don't have the courage to ask it. So there are no dumb questions, guys. So don't come and apologize to me because you didn't get the subject. I have some students that are like, I'm so sorry I didn't get the subject. I'm like, don't worry. I didn't get it at the first time. I remember when my dad was explaining all of these circuits to me, he would get so mad because I wouldn't get it. I'm like, I'm sorry, I don't get it. I don't understand what you're talking about. It's like, and he would explain it and explain it and explain it until it clicked. One day it clicked. And then I was like, oh, okay, I get it. So everything got a little bit easier and easier and easier. But you need to ask questions, and you also need to be patient with yourselves, okay? All right? Are we good?
Yeah.
All right, guys, so let's go ahead. Does everybody have my information?
Good morning.
Good morning. Thank you very much.
Yeah.
All right, so everybody has my information?
Yes.
All right, so let's go ahead and start with our class today. So we need to talk about electricity.
Electricity.
Okay. So how do, yes,
I have a notebook, but I don't have like a pencil or pen.
all right.
打个电话不好用。是吧？
All right.
我只能听懂本文的单词，差不多。
Okay. I'm sorry? Paper?
为什么会electricity 呢？
就是 electricity，我们学的就是 electricity。
city 不是城市吗？
对。
这下面有东西，离的下面有东西。啊，听懂了吗？听不懂，一点没听懂。我能听懂的大概。
Okay, guys, I have a coffee maker right here. I have coffee, I have sugar. If you guys need to make coffee, feel free. Just make sure that the classroom is clean, okay? If you guys want to eat here in the class, I have no issue because I know some of you guys work at night and you're here after your night shift, so I get it, you're tired. But I don't want any crumbs on the carpet, okay? If you guys eat here, you need to throw your trash, and if you guys want to use the coffee maker, before you leave, you have to clean it, all right? The microwave is there as well, the refrigerator as well is there, but if you guys make a mess, make sure you clean after yourselves, okay? Okay, so we're gonna talk about electricity. How do we create electricity? How is electricity here in this receptacle, for example? How does it get from somewhere to here? Does anybody have any ideas? How do we generate electricity?
Solar.
Hmm?
The water?
Well, yeah, so we use water. How do we use water to create electricity?
Spin turbines.
It's spin turbines, right? So most of our electricity is generated by different sources of power, right? So you know that we use gas, we use coal, we use wind, we use water, we use the heat inside of the earth also, right, to spin turbines. Those turbines are being spun, and that is a generator. So the turbines of a generator are being turned, and these are creating electricity. For example, this is our generator right here, and there is a power source that could be water, it could be wind, it could be coal, it could be gas. All of these could be our power source. This is how we're generating our power, and we are connecting wires to the generator. And these wires are traveling for long distances until they get to where we want them. They can go to homes, they could go to commercial buildings, they could go to small cities, or they can go into a power station, and in the power station we create more energy so that it travels all the way here to the city, so that it can go into our grocery stores, it can go into our homes, right? We have our homes need electricity, so we need to be able to bring the power, and the power usually comes into an electrical box, and it's traveling for long distances until it gets to this home where we're bringing in the power, and this is powering up our receptacles, our lights, everything that we have in our home, right? But there has to be a way to generate power. We also generate power with sun, right? We have solar. So the solar panels also will create a power source. Now there are power sources that are very, very powerful. There are other power sources that even though we wanted them to be much more, like for example water, wind, and solar, we wish we could create more power that is clean power with these sources, but unfortunately they don't create as much power as we need. So we have to depend on coal, we have to depend on gas, and we also have to depend on chemicals, right? Because chemical plants will be the most that we can use to generate our power that our cities need, because we have electric cars now. They want us to have electric gas stoves, they want us to have electric water heaters, they want us to have electric dryers. Everything has to be electric, right? So we need a lot of power, so unfortunately we have to tap into chemical, gas, coal, and other types of power sources that are not as clean as wind, water, or solar. But this is what they're working constantly all of the time, creating new technology to be able to make this better. So our energy, our electricity has to travel until it gets to a certain place. Now, when we have our energy traveling, it has to travel through conductors. The code, the electrical code, will call them conductors, because they will allow current to flow through it. So a conductor is, a conductor will allow it will allow current to flow through it. Now, current is the flow of electrons. Now, all around us, we have atoms, and our atoms have electrons and they have protons. Now, our electrons are inside of our conductors, so there are materials that are very good conductors of electricity. For example, this aluminum part right here of this board is a very good conductor of electricity, and sometimes when I touch it I get shocked, like I get little shocks, and that's because of static. Why? Because there are electrons all around us and there's a buildup. So when there's a difference between me and this aluminum, now I get shocked. Have you guys gotten shocked with metal parts, with handles, with anything like that? Well, it's because electrons are all around us. This metal right here is a very good conductor of electricity. Now you would ask yourselves, if it's a very good conductor of electricity, why do we use it in our electrical systems? Well, because they're also very good to protect our conductors that are inside. So if we're talking about commercial installations, we want something that's hard, that's sturdy. We want something that will protect the conductors that are inside. So here we have conductors. We have wires running through this pipe, coming into this box and into this receptacle. Now the reason why we use it is because there's a lot of traffic here. There's a lot of students, there's a lot of people that can come in and they can hit these wires if I just run them exposed on the wall. So we need to protect those wires because those wires are the ones that are allowing current to flow. Now current is the flow of electrons. Now through these conductors right here, in theory, right? This is just electrical theory. In theory, through these conductors, there is a flow of electrons. This is what we call current. It's flowing freely, and as it's flowing, it is creating what we call electricity. But we need to have certain things to be able to create a circuit. So we need conductors. What do you guys think is a good conductor of electricity? I already said metal. I said aluminum, right? Silver, good.
Gold.
Gold. What else?
Copper.
Copper. Now,
Seven.
有
Oh, seven.
silver,
Silver.
silver
Silver.
copper, aluminum, silver, gold. These are very good conductors of electricity. Now, what do you guys think is the difference between all of them?
Price?
Price, exactly. You imagine if I wire my house with gold? Whew, they would come and steal all my gold the following day because people want all of that material that is expensive to resell it. So price-wise, metal is a good conductor of electricity, aluminum is a good conductor of electricity, silver is a good conductor of electricity, gold is a good conductor of electricity, and copper is a good conductor of electricity. But the code only allows a certain type of material to be used as a conductor for safety purposes, because not all of these alloys are good for conducting electricity safely. Some of them will allow electricity to flow, but they also will not be good enough to be able to allow electricity to flow safely through them. So the code allows a certain material to be used as a conductor, so that in those conductors, the flow of electrons is easier than if you use other materials that are not conductive. Now, we also need insulators. Now, insulators will resist the flow of electrons. So we need to have some type of insulation so that electricity does not flow where we don't want it to flow. For example, I want the electricity to flow from these switches to those lights. But I don't want them to flow anywhere else. I just want them to go up to those lights through the conductors that we already ran. So we ran conductors from these switches all the way to these lights, and these switches are insulated. They have an insulation so that when I touch it, I'm not getting shocked, but electricity is flowing through here. Did you hear that little, did you hear that? That's a little arc that's happening right there because the contacts are touching and current is flowing, and when the contacts get close, they make a little arc. So these devices are made for electrical systems, and they're made with certain materials that will be safe for us to be able to touch. Now there's electricity right here, but I can touch this receptacle and the electricity is not gonna flow through my hand because it's insulated. It only allows current to flow when you plug something in, and through the device you press the start. So if I were to bring that microwave right here, I would plug it in, and only when I press the start button will that microwave start turning and creating that heat. If I bring that coffee maker right here, I can plug it in, but only when I turn that start button will that coffee maker start pouring in the water into the coffee maker. Not when I plug it in. When I plug it in immediately, it's not gonna turn on, right? Because they all have a button that serves the purpose of a switch. If these lights didn't have a switch and I just ran wires all up over them, then I wouldn't be able to turn them off. So I need to have devices that will allow me to control the switches. So